All right, I am going to solve one problem from this grams to grams worksheet, and I am going to pick 1b. And the balanced equation is given to us right here, and the chemicals that I'm interested in, the components that I'm interested in are carbon dioxide, so that's this one, and the F3O4, and that's this one. Did I say F3O4? Fe3O4, sorry. Anyway, to solve problems like this, what do we need? Well, we need to have the mole weights. And how do we get those? We add them up off the periodic table. So we get the mass of iron atoms and oxygen atoms, and we take iron times 3 plus oxygen times 4, and we wind up with 231.53 grams per mole. And then for the carbon dioxide, one carbon plus 2 oxygens, it gives you 44.01 grams per mole. Paying attention to these decimals in some classes is probably a big deal, but when I wrote my problems in Moodle, all I did was I said accept answers that are close enough to within 2%. So if you don't worry about these decimals quite so much, maybe you leave off the hundredths place. If you did that in this class, you are probably going to be fine. What else do you need? We need to pay attention to the balanced equation, and we've got no coefficient in front of this iron-oxygen compound, so that means it's just a 1. And then in front of the carbon dioxide, we have a 4, so we've got 4 here. So we need to know those things. So the equation has to be balanced. So the reason we need to know the mole weights is because different compounds have different masses. You know, if you have some Fe3O4 and the same number of moles of CO2, the Fe3O4 is several times more massive. And the reason that we have to have the equation balanced is because mole for mole, you're going to need 4 times as much CO2 as you need of the Fe3O4. So starting this problem is just like starting lots of problems in this class. We were given this quantity right here. So I'm going to write 0.945 grams of Fe3O4. I would love to be able to just switch grams of one thing to grams of another, but I've got to take into account this ratio, this 1:4 ratio. So to do that, I need to get them both into moles first, or get it into moles first. So I need to get rid of grams of Fe3O4, and I need to go to moles of Fe3O4. And if you think I'm writing too much stuff here, writing my compound formulas every time and my grams, my moles, I'll mess up if I don't do it. So that's why I do it. So let's see here. My Fe3O4, 1 mole is 231.53 grams. So by doing this, that cancels out my grams of the Fe3O4. So now what am I in? If I stop now, I'm in moles of Fe3O4. So now I need to convert from one chemical to another. And that's what the balanced equation does for us. We use these mole ratios because that tells us the relative amounts of each compound, mole for mole. So for every 1 mole of the Fe3O4, there's going to be 4 moles of CO2. So if I want to cancel out my moles of Fe3O4, it's on top, I'm going to write it on bottom. And instead of Fe3O4, I want to talk about CO2. And the numbers that I fill in here then are from the balanced equation. 1 for the Fe3O4, because it didn't have a coefficient, and then a 4 for the CO2. So now what I've canceled out is the moles of Fe3O4. So if I stop now, I'm in moles of CO2. So I'm headed to where I want to be because the question says how many grams of the CO2. So next, I want to cancel out moles of CO2, and the question asks for grams. So I want grams of CO2. So now I go back to my mole weight here for CO2, and 1 mole of CO2 is 44.01 grams. And what do I cancel out now? Now I cancel out my moles of CO2. And what am I left with? I am left with grams of CO2, which is what I wanted, so that's a good thing. So let me get out my calculator here. And I'm going to multiply across the top. So I've got my 0.945 times 1 times 4 times 44.01. And then I'm going to divide by the bottom. And the only number I have on the bottom is this 231.53. And I wind up getting 0.7185. I'm only going to go out a couple decimal places here, and I'm going to have 0.72. So my answer is 0.72 what? Grams of CO2. And there you go.